Hello? Am I recording? Am I recording? This is how I start my videos now. Yes, do I have permission to record? Yes. Am I recording? No. This is for Leilani. I will be emailing. Hey, let's get started. The sooner you start, the sooner you have your break, because your break's when you finish this. We'll see. Depends how fast you work. All right, before we learn the ratio test for convergence, this is extremely important, by the way. We need to go over some like preliminary stuff here and practice simplifying with exponentials and factorials. Okay, so I'm going to show you numbers 1, 2, and 3. Okay, so number 1, practice simplifying. Here's how you want to simplify. You know, I'm always telling you to break up exponents. That's how you would simplify this, by breaking up the exponents just like this. And then you see now we can cancel the 2 to the power of n's, leaving behind just a 1/2. Okay, number 2, so same thing. To simplify this, break up the exponent, and then cancel. The e to the n's, so e to the first power is just going to be e. Obviously, hopefully, like eventually you'll be able to simplify this in your head, but for now we're like practicing expanding and like breaking up the exponent. Hey, we're doing factorials in calculus. You've seen this before, yeah? Do you see this in AP Pre-Calc? No. No? Algebra 2, though. Algebra 1? No, Algebra 1, yeah. Geometry, huh? Catherine? Algebra 1 or 2? Oh, 2 plus? Yeah, 2 plus does it. Do you remember anything, Drew? All right, here's what a factorial means. Pay attention. 3 factorial, this just means you're multiplying all the numbers up until 3 like this. 1 times 2 times 3. 4 factorial, you're doing 1 times 2 times 3 times 4. Hey, and then to simplify, pay attention, Timmy. You just cancel like this. 1 times 2 times 3. Okay, here's how you simplify. All right, can you do the remainder of the warm-up? 4, 5, 6. Wait, I'm gonna add one more. I just don't remember what it was. Can you add this one? Don't look at that. Make this your number 7, n plus 2 over n factorial. Is that what I had written? Sorry, n plus 2 factorial over n factorial. Okay, so you have 4 problems here to finish in your warm-up. Try those out right now. Hey, Leilani, I'm recording for you, but you just got here, so I'm just gonna keep recording. Five, 4, 3, 2, 1. Hey, let me show you 6 so you can try out number 7. All right, so up to n factorial. So funny to me. All right, so n factorial, n's just a general number, so you do it like this: 1 times 3 times 4 times dot 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 all the way up to the nth term. N is like a general number, like 10, 30, I don't know. But the point is, like, you count for starting from 1 ending at n. Same thing with n plus 1, starting at 1 times 2 times 3 times 4 times dot 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 times up. So like, look, every time, like, you're adding 1 every single time, right? Like, each term, this is a little squiggly, is being like added by 1 when for the next term that you multiply. So like, you're doing times up into n, and then the next term after that is n plus 1. Again, because like the next term you multiply increases by 1. So it's times n plus 1 like that. And then cancel all the way up to n. This will simplify to 1 over n plus 1. Okay? You try that out with number 7. I'll give you about 1 minute. I added a 7, don't you remember? No, what? Yeah? Not with factorials. You have to like expand and then cancel. Four. 1. Okay, by the way, I put 4 up here. No, 5 up here. When I show test, it feels like this when it's n. Real. Let me go over the 7th one here. So starting at 1 times 2 times 3 times dot 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 times, then you go to n, and then you add 1 to every term that you multiply to. So times n plus 1, and then if you add 1 more, that's times n plus 2. You stop because it's n plus 2 factorial. Okay, and then on the bottom, 1 times 2 times 3 times up to n. No whispering right now. Okay, it's a math question. Okay, cancel, and then this is what you're left with. Okay, cool. Moving on. Here's the ratio test. Another test. Okay, here's how the ratio test goes. Actually, before I tell you what the ratio test is, I need to go over some notation. Can you write this? I don't want any talking right now. It's very distracting, and I can't deal with it this whole hour and a half with the talking. All right, notation examples. You're gonna see you're gonna see this, but for example, if you have a sub 4, the little 4, you say sub 4. This means the 4th term in the series. 4th term in the series. So you know how you can expand starting at n equals 1, plug in 2, 3, 4, up to infinity. The 4th term, the notation for that is a sub 4, just like for example, if you have a sub 5, well, this is the 5th term. Okay, I want to go over this sub n plus 1. Okay, so look, a sub 4 is a fourth term, a sub 5, if you add 1 to 4, right, 4 plus 1 is 5, that's just going to be the fifth. A sub 5 is the term right after a sub 4. So same thing here, this a sub n plus 1. The n plus 1 makes it so that this is the term that comes after a sub n. Okay, this is a term that's right after a sub n. Okay, and again, a sub n, it's general. It could be like the sixth term, a sub n plus 1. That means it'll be the seventh term, the one right after it. Okay, because you're going to see that when we talk about the ratio test criteria. Okay, so let a sub n be our infinite series. All right, first rule, the series converges if you do the limit as n approaches infinity of a sub n plus 1 divided by a sub n is less than 1. So basically what you're going to do here is you're going to do the limit of the ratio, this a sub n plus 1 divided by a sub n. When you're dividing two things like that, it's a ratio. A fraction, it's a ratio. You're going to do the limit of the ratio. If it's less than 1, the series converges. Okay, the rule for divergence is if you get that the limit is greater than 1, the limit of the ratio is greater than 1, diverges. This is similar to another test we already have. Not super similar, but isn't that the same for geometric series test? If the ratio, common ratio is less than 1, converge. Greater than 1, diverge. These are tricks that I do with my brain to help me memorize these rules, so that's why I'm making that connection with you guys. You know geometric series, you have that memorized, so just relate it to that to help you remember it. Ratio test is inconclusive if limit as a sub n equals 1. I've never seen this happen before, so we can just ignore that. Okay, ready? Oh no, wait. Before we do examples, here's the question. Why do we need another test? Okay, it's to deal with weird-looking series. Look at these examples. These are weird, not geometric, not P. Okay, so ratio test, you need it to deal with weird-looking series. Weird-looking series, like, for example, if you have like n squared times 2 to the power of n over n plus 1 factorial. So you got a mix of like a P series, a geometric series, and a factorial. It's kind of nice because it's like, how do you know when to use ratio test when it looks crazy like this? Or like basically whenever you see a factorial or an exponential mixed with a power, that's when you do this test. Okay. So use this test on factorials. And if it's like exponentials mixed with something. And exponentials. Exponentials. All right. We're doing ratio tests for all of these. There's no other possible test you can do on any of them. Okay, number 1, determine if the series converges or diverges. So here's how you know how to do ratio tests. Look, there's a factorial. Maybe some of you guys are still confused and you're like, wait, but there's an exponent of n. This is geometric. This is not geometric. It would be geometric if this guy wasn't here. Then it would be a geometric. So if it was just 2 to the power of n, this is geometric. But since we have this n factorial, it's not. Ratio test is takes a little bit of time, but I just want to show you nth term test for divergence wouldn't work on this because, in fact, exponentials do not increase the fastest, at least not anymore. The factorials increase the fastest. So if we did limit as n approaches infinity, this would be 0. Nth term test inconclusive. Inconclusive. Wait, we should write somewhere that factorials grow faster than exponentials. Yeah, because we're going to be doing limits of factorials too, actually. Or should we write it? Wherever. Wherever you have room. Factorials grow faster than exponentials. All right, we have no other choice but to do ratio test. Here it is. All right, so look at the formula. It's a sub n plus 1 divided by a sub n. So what you're going to do first is anywhere you see n, you're going to replace it with n plus 1. Like this. We'll first start with the limit notation. Limit as n approaches infinity. And it's absolute value, so put giant absolute values. Okay, a sub n plus 1. That means anywhere you see an n, replace it with n plus 1. So 2 to the power of n plus 1 over n plus 1 factorial. And then divided by a sub n as a formula. So divided by a sub n, that's just dividing by the original series, right? Because a sub n is what's like in your series right after your sigma. Okay, so divided by a sub 1, so divided by 2 to the power of n over n factorial. All right, here's what we're going to do now. So we just set up the ratio. What we're going to do is simplify and then do the limit. First thing to simplify, ready guys? Keep, change, flip. Right, teeny tiny. Right, microscopic. You're going to need like 4 lines total room here. Okay. So keep, change, flip. Keep the top one the same, 2 to the n plus 1 over n plus 1 factorial. Change to multiplication, and then don't forget to flip the bottom one to n factorial over 2 to the power of n. Okay, keep, change, flip. It's really hard not to write KFC right now. Okay, here's what we're gonna do next. We're gonna clean this up by grouping terms that are similar together just to get it just so we can simplify easier and calculate the limit faster. So group like terms together. Let's see, 2 to the n plus 1 and 2 to the power of n. Those are both exponentials, so we'll put those together on top of each other like that. Exponentials will also be grouped together, so n factorial over n plus 1 factorial. Okay, now that we've grouped these together, oh, don't forget your absolute value and your limit notation every time. We're going to simplify. This is just like the warm-up here. Okay, so when we simplify the exponential, the n plus 1's in the numerator, so that's going to leave behind just a 2. Gotta put my limit notation here again. And then n factorial over n plus 1 factorial, that's problem number 6 in the warm-up. That's just 1 over n plus 1. Okay, so we simplified. Last step is we do the limit. Limit of a constant is just a constant. Limit of 1 over n plus 1, n's in the denominator, no n in the numerator. Limit of that's going to be 0. So 2 times 0 is 0. Now, is 0 less than 1 or greater than 1? That's stupid. Less than 1. Yeah, of course. I don't even know why I asked you that. It's less than 1. So according to the ratio test, the series converges. This ratio is less than 1. We don't know what it converges to. All we know is it just converges. Okay, that's it for number 1. Ready for number 2? All right, that's the most basic example. Are there questions? All right, stop talking. Okay, number 2. All right, this is crazy looking. Doesn't it feel ratio testy? There's no exponentials. Sorry, there's no factorials, but it's still ratio test. This is not geometric. Look, this would be geometric if I erase this n squared. If that was not there, you would do geometric series test. But that n squared is there, so we're going to do ratio test. First thing you do, replace any n with n plus 1. N plus 1 squared times 2 to the n plus 1 plus 1 over 3 to the power of n plus 1. Okay, there's my a sub n plus 1. Again, all I did was replace n with n plus 1 and then divide it now by a sub n. You divide by just your original series. This is a sub n right here. That's a sub n. N squared times 2 to the n plus 1 over 3 to the power of n. Next step, you're going to do keep, change, flip. Limit as n approaches infinity, n plus 1 squared times 2 to the n plus 2. Actually, I'm going to simplify here. N plus 1 plus 1. 1 plus 1 is 2. So we'll just make the exponent n plus 2, okay? N plus 2. Whoa. Over 3 to the power of n plus 1. So keep, change to multiplication, flip the bottom one to 3 to the power of n over n squared times 2 to the power of n plus 1. Okay, now we're going to group things that are similar together and then simplify from there later, Fedor. Limit as n approaches infinity. Let's see, what should we group here? N plus 1 squared is going to go with this n squared. N plus 1 squared over n squared. What else? 3 to the n plus 1 and 3 to the power of n. Those go together. And then the 2 to the n plus 2. And 2 to the power of n plus 1. We group those. It's nicer when you group stuff together. I feel like maybe you'll make less mistakes when you simplify like this. All right. What should we simplify first? Okay, this guy, first of all, doesn't simplify. N plus 1 squared over n squared, that doesn't simplify. We're going to be doing the limit of that, actually, as n approaches infinity. So we'll leave that there for now. Let me simplify these guys first. 3 to the n plus 1. Wait. This guy simplifies to 1/3. You know, because the n plus 1's on the bottom, leaves a 3 on the bottom. And then this guy is going to simplify to just 2, because there's one more 2 in the numerator than the denominator. Okay, and this guy we're going to do the limit of as n approaches infinity. Again, this does not simplify. You can't be canceling weird things like that. Okay, to do the limit of this, you look at the degrees. Look, the degree in the numerator and denominator are the same, so the limit's going to be the leading coefficients of n, which are 1. So the limit of this is 1 over 1, just 1. Okay, multiply all these together. That's 2/3. Okay, after we've done the limit, is the limit greater than 1 or less than 1 is the next question you ask yourself. Less than 1. Converges by ratio test. What's your question, Hayden? Where it's what? No, we don't know what it converges to. I know. I'm sad too. I'm gonna do one more. Any other questions before I do one more fast with you? I really like number 3. Okay, I'm gonna do it. Limit as n approaches infinity, n plus 1, this is crazy, to the power of n plus 1 over n plus 1 factorial. Hey, you guys are big kids. Why don't we just jump straight to doing keep, change, flip? Yeah, let's do that. So here's a sub n plus 1. Instead of dividing by a sub n, I'm going to multiply by the reciprocal of this guy. Let's just always do that, yeah? Just go straight to multiplying by the reciprocal. Okay, good. This is a good one. Okay, n plus 1 factorial and n factorial, those guys are going to go together. What else? N plus 1. Okay. Is that you, Pearson? Thought you were the one snacking. All right, I've grouped stuff together. Let's see. I can cancel factorials. This will cancel and leave an n plus 1 behind in the denominator, 1 over n plus 1. Gotta write your limit notation. I can't cancel anything here. But let's break up this exponent, that n plus 1, and just see if things happen. Because we're trying to simplify. Okay, so I broke up that n plus 1 exponent just like this. Still over n to the power of n. Are you watching this? Okay, then we can cancel these n plus 1s, because there's one on the bottom and the top. Okay, absolute value of n plus 1 to the power of n over n to the power of n. Can you do the limit of this? Yeah. Wait. Can you come whisper it to me? Whisper to me. Here, what if I write this a little bit differently? Maybe you can figure out what the limit is. Do you know how to whisper? Not really. Do you know what the limit of this is? It's not what you're whispering? Okay. Because I want to see if you know what the limit of this is. Alright, who's got an answer for the limit yet? Yeah, but can you tell me what the limit of the value is? It's not infinity. Yeah. I don't know what that means. Okay, go to your seat. Tell me if you can figure out the limit of this. I want the number. Hey, are you talking about math over there? You should only be talking about math. Hey, what if I break this up like this? We've done this before. We break up fractions like this, n over n plus 1 over n. And raise that all to the power of n. Does this do anything for you? Are you able to see what the limit is yet? Can anybody give me an answer? Hey, n divided by n, we can make that 1. You must think long and hard about this limit. 1 plus 1 over n to the n. Does this look like anything to anyone? Wink at me if you know what this limit is. You do? Anyone else winking? Okay. Alright. Since you can't give me answers, you're gonna find the limit on your calculator. Why don't you plug in a real big number for n, since n is approaching infinity? Type this in, 1 plus 1 over 1 million. Hey, that's real big. To the 1 millionth power. No, it's not 1. Did you type it in? Like, what's the answer? What is it, Leela? What is this number? It's E. This is E. This is a definition of E. I'm always throwing it at you randomly. That's the definition of E, by the way. Okay, E is greater than 1. Alright, diverges. Okay, can you do the rest of the packets? I know, pretty cool. Pretty cool. Okay, can I stop recording now, Leilani? Yeah? Or no? No. Because you're not gonna come to class anymore. Why do you hate me? That's why you're laughing.